Okay, we are moving into the big leagues here. So these are more consecutive integer problems, but they are not the easy kind that we talked about last time, where we're just told that the sum of two consecutive integers is a certain thing, or the sum of three consecutive odd integers is a certain thing. These are definitely more challenging. So let me just read the first one here. Find two consecutive integers such that the larger is 9 more than twice the smaller, right? So if you were disregarding my request last time to set them up the way that we did before, you're going to look at a problem like this and think, I have no idea how to do it, all right? So let's just talk through this one, and hopefully when you get to the end, you'll think, wow, that wasn't that bad. So the first thing it's telling us to do is find two consecutive integers. Again, notice it doesn't say even integers or odd integers, just two consecutive integers. And we know that the larger one is 9 more than twice the smaller. Okay. Again, this is intimidating when people look at it, but in just a second, hopefully you'll be like, oh, not too bad. Okay, so find two consecutive integers. So let n equal, now I'm going to use the terminology that they use in here. They call one the larger and they call one the smaller. So let n equal the smaller integer. I'm just going to abbreviate int. And then the larger one, because they're consecutive, it's just n plus 1. All right, easy so far. Now what we're going to do is, it's telling us find two consecutive integers such that, or have this property. And here it is, the property. The larger is 9 more than twice the smaller. So let's go through and we're going to translate this, kind of like we did for percent problems. We'll translate it and fill in replacements here. So the larger, they're talking here about the larger integer. I don't know what it is, but I just named it n plus 1. So I'm going to replace this with n plus 1. Is, what did we say that usually represented in math symbols? Hopefully you remember that was equals. So is, I'm translating into equals. 9 more than twice the smaller. So let's talk about twice the smaller for a second. All right, so twice usually means multiplying by 2. In fact, I can't think of an instance when it doesn't. So it's saying twice, what? Twice the smaller. All right, the smaller was n, so twice the smaller is 2n. All right, and then it's telling me to do 9 more than that. All right, 9 more than means add 9. All right, now you might say, Mrs. Taylor, why didn't you do 9 plus 2n? You could have, except it's telling us that it is whatever we have, it's more than this. All right, so we start with this and then we add on to it. So it's more than twice the smaller. We put twice the smaller and add 9. Now, could you have written 9 plus 2n? Yes, you could have. However, I want you to get in the habit of putting this first when it says something like 9 more than, because when we get to things like 9 less than twice the smaller, order is critical because subtraction is not commutative. So I want you to think about this. I'm taking twice the smaller and I'm looking for 9 more than that. So that's why I'm putting the plus 9 after the 2n, because it's 9 more than what? 9 more than this. Okay, so we have just translated this sentence right here into this algebraic equation. And now we get to do the easy part, and that is solve. So first thing is we're going to subtract n from both sides. We get 1 equals n plus 9. I'm going to subtract 9 from both sides. This might be where you get a little bit weirded out. 9 minus 9 is 0. So on this side, they just cancel out and we have n. And then 1 minus 9, again, remember, these are integer problems, so we are going to get negative numbers sometimes. And this is one of those cases. 1 minus 9 is negative 8. Okay, so then that tells us that the smaller integer is -8. Now, we have to think of the larger one. We get that by adding 1 to this. Don't tell me -9, because that subtracts 1. We want n plus 1, 1 more than this. That would be -7. All right, let's check it out. Is the larger, which is this one, 9 more than twice the smaller? Well, let's do twice the smaller. Twice the smaller would be -16. And if we add 9 to that, what do we get? -7. So is the larger 9 more than twice the smaller? Yes, it is. All right. So the two integers are -8 and -7. All right, think about that. If that's messing you up right here, think about this. If I take twice the smaller and add 9 to it, I get -7. Is that the larger? Yes, it is. Okay, let's look at the next one. The next one says, find 3 consecutive even integers. Circle that, do whatever you need to. A lot of times people overlook that and they just do 3 consecutive integers, such that, again, this is telling us here comes the property that we're looking for. The sum of twice the first and 3 times the third is 14 more than 4 times the second. It sounds way worse than it is. Let's just write down our 3 integers first. Okay, so let n equal, they call it first, second, and third. So let's say let n equal the first integer. Then, because they're even, again, we're not going one right after the other. We're skipping over the odd integer. So this is actually n plus 2 equals the second integer. And then n plus 4 equals the third integer. Okay. Sorry, I have all these pencils here, but none of them are sharp. This one should be good. Okay, so let's see what it tells us to do. All right, when it says the sum, that means get ready to add. All right, so it's going to tell us to add 1 thing, 2 things, we don't know what, but I'm just going to get ready. So when it says the sum of, it means we're going to add things. And then I should include that, the sum of. And then after that, it tells us what to add. All right, so it's saying twice the first and 3 times the third. All right, so in this first blank, we're going to put twice the first. What's the first? N. So twice the first and 3 times the third. All right, so in the next blank, I'm going to do 3 times the third. There's the third integer right there. All right, the next word that comes is. That means equals. And it's 14 more than what? 4 times the second. So we have to put 4 times the second here, which is 4 times n plus 2. And then we have to do 14 more than that. And again, I'm asking you to do it in that order because when we get to subtraction, you won't have a choice. So if we get used to it now, it'll be easier. All right, so the sum of, add together, twice the first and 3 times the third, and that is, or is equal to, 14 more than 4 times the second. All right, this one's a little bit more challenging to solve because we have to use distributive properties. So remember, that's our first step in solving algebraic equations. So leave the 2n here plus, all right, this means multiply the 3 by each thing in here. So this is 3n plus 12. Please don't say 3n plus 4 because we have to do the 3 times 4 equals, and then we've got to distribute here, 4n plus 8, and then plus this 14. Okay, then this becomes 5n plus 12 equals 4n plus 22. Okay, let's subtract the 4n from both sides, move all the variables to one side, and I always choose to move the smaller over to the larger. So then we get n plus 12 equals 22. Now I'm going to subtract the 12 from both sides. And I get n equals 10. Right, so that is the first integer. I'm just going to put them right in here and then we'll write them out. That's the first. The second one is 2 more than that, so that's 12. The third one is either 2 more than the second or 4 more than the first, so let's go with 14 right here. Right, so let's try this. The sum of twice the first, all right, so twice the first, that would give us 2 times 10, and 3 times the third, 3 times the third, is 14 more than 4 times the second. Let's check it out and see if that works. That's 2 times 10 is 20. 3 times 14 is 42. Is that equal to 48 plus 14? Let's check that out. That gives us 62 equals 62. Yeah, it does work. And again, I'm not requiring you to check that, but sometimes it just helps in your brain to think about, does this actually work? These are nice, easy ones for you to just kind of mentally figure out whether that makes sense. So let's answer our question then. Not let. We would just say the integers are 10, 12, and 14. Okay, in the next video, we'll do the next 2 problems.